Welcome everyone to the last outline of this course, which is class imbalance. So let's get started. Before we move forward, let's have a recap of what is class imbalance, and then we will move towards the practical work in which we will learn how we can handle class imbalance using R. So what is class imbalance? Class imbalance in data science refers to a situation where the number of instances in one class is significantly lower than the number of instances in the other classes in a binary classification problem. This means that one class is overrepresented while the other is underrepresented. An example of class imbalance which we are going to handle in today's lecture is about cross-sections dataset that contains thousands of cross-sections that are not fraud. However, in the same column, we also have some cross-sections that are fraud. So you can realize that the fraud cross-sections in the cross-sections dataset is underrepresented. So let's move forward. What is the cause of class imbalance? The causes of class imbalance can vary depending on the nature of the problem. Some of the causes include data collection bias, rare events, natural occurrences of the phenomenon being studied, or the cost of data acquisition for the minority class. Now you might be wondering that what effect does it have? Class imbalance can have significant impacts on the performance of machine learning models. Since the algorithm is designed to maximize overall accuracy, it may ignore the minority class, resulting in poor predictive performance. However, modeling is not a part of this course, but we should know that how class imbalance affects it. In addition, the model may predict the majority class in all cases, leading to a high false negative rate for the minority class. Let's see the steps for class imbalance. There are several techniques for handling class imbalance in data science using R. Some of the popular methods include oversampling and undersampling. So now let's try to understand random oversampling. Random oversampling is an oversampling technique employed to deal with class imbalance in machine learning. It selects instances at random from the minority class and produces synthetic instances by interpolating between present instances of the minority class. This procedure leads to the creation of a more balanced and larger dataset that facilitates the model's training process. So here you can see that how random oversampling is done. Let's say you have the cross-sections dataset. Now this is the class that contains the cross-sections that are not fraud and is represented by 0. However, this is the class that is represented by 1, and that includes the fraud cross-sections. So after the random oversampling, you can see that the minority classes have generated synthetic instances equal to the number of non-fraud cross-sections. So now let's move to our studio to see how we can do random oversampling. Well, first of all, I will read my dataset in the variable of France, and I say read.csv, and here I pass the file name transsections.csv, and now I will say head trans. Now this might take a while because the dataset is too large. As you can see, the size is almost 456 MB, so it will take a while to be loaded in our studio. Now you can see your dataset has been loaded. These are the columns with rows, and here is your target variable is fraud. That contains the cross-section 0 and 1 value, and if it's 0, it means the cross-section is not fraud. However, the one value indicates that the transaction is fraud. So first of all, let's try to get some basic information about dataset. I'll use the str function, and here I can see the data types. All right, so it looks good. Well, first of all, what I'm going to do is to create two variables and store the count or number of instances for the fraud and non-fraud transactions. So first I will say class count 0. And inside this variable, I say sum trans, and I say take this fraud data set, and if the value is equals to 0. And similarly for the class count 1, I will say the same. I will say sum trans and take this fraud column, and if the values are equal to 1. And below here, I will say cat, and I will say original count of class 0. And here I will say take the class count 0 and just enter a new line as well. And similarly for the class count 1, I will say original count of class 1. And here I say class count 1. And I enter a new line once again. Now let's run it. Well, you can see the count for class 0 is too much. And this is the count for class 1. And you can clearly see that the class 1 is underrated. So we need to handle class imbalance here. And the very first technique that we are going to use is random oversampling. But before that, I will first create two more variables with the name of minority class. And inside this variable, I say take the transactions dataset, and here I will use this sign. And I will say go inside the transaction dataset and filter the information. And I say take the is fraud column, and if the value is 1, then it would be the minority class. And for the majority class, I will say trans and then filter the information from the is fraud column. And if the information is 0, then put it in the majority class. And before running, I set set.seed, and now we'll run it. Oops, I forgot to load the library at first because I'm using this function here, and I will say library deploy. All right. Now let's do it again. Perfect. And now what I'm going to do here is that I will say oversampled minority, because I'm going to do the oversampling, and therefore I will take the minority class. I will say minority class, and then I use this. And now I will say sample n, which is going to create random n samples of the minority class. And I will say make it equal to the size of n row. And I will pass the majority class here. And in the last, I pass one more parameter, which is replace equals to true. And here I say oversampled cross section. dataset, and I use the rbind function. And first I pass the majority class and then our sampled minority. Great. And now let's just count the number of instances for each class. I will say class count 0 once again. And here I say that sum. And what to sum is our sampled cross-section dataset column is broad having the value of 0. And I will say almost the same for class count 0. I will say sum our sampled cross-section dataset and take the is broad column. And if the value is equals to 1, let's just run it. And finally, I say cat and I say resampled count of class 0. And I say class count 0. And similarly, I say resampled count of class 1. And I say class count 1. And let's see the output. Great. So you can see that the resample count of class 0 is 63 lakh and something. And the count of class 1 is now also 63 lakh and something, which was 7,717 before doing the random oversampling. So this is how you can deal with class imbalance using random oversampling. Now let's get back to our studio. Well, next we have random undersampling. In machine learning, undersampling is a technique utilized to address class imbalance by reducing the size of the majority class to achieve a more balanced dataset. This approach randomly removes instances from the majority class until it is similar in size to the minority class. While this method may result in a reduction in the amount of information available for the model to learn from, it can be beneficial in situations where the dataset is too large, such that, in our case, or when generating synthetic data is not feasible. So this is how it works. You have this minority class and this majority class. After doing the random undersampling, the samples are taken from the majority class, which are equal to the size of the minority class, which is 1 in our current case. So now let's move back to our studio. Well, first of all, I will say head cross-sections and then str, and here I print the count for class 1 and class 0 once again. And you can see the count for class 1 is this, and the count for class 0 is this. So now what I'm going to do is to do random undersampling, which will make the count for class 0 equal to the count of class 1. Here I have loaded the library, and I have also made the minority class and majority class variable already. And here I'm going to do the coding. I will create a variable with the name of undersampled majority. And inside this variable, I say take the majority class and go inside it. And I use the sampleIn function. And I pass the size equals to number of rows of the minority class, because I'm going to do undersampling. And here I say undersampled cross-section dataset. And I use the rbind function. And here I say undersampled majority. and take the minority class. Now let's run it. Perfect. So now let's create the count for each of the class after doing the random undersampling. I say take the sum function and take the undersampled trans dataset and its broad column, and if the value is equals to 0. And for the class count 1, I will say if the value is 1, and I'm going to use the same print functions from above. All right, now let's see. Perfect. So you can see that the class 0 has been undersampled and is equal to the class 1. Now let's move back to slides. So guys, today you have learned about how to deal class imbalance using undersampling and oversampling technique. So I have got some homework for you. Your homework is to apply the class imbalance techniques that you have studied today. And this is the link of the dataset on which you can practice. Now, good luck. See you next time.